tu peux y aller.
Alors bonjour à tous, à toutes et à tous, n'est-ce pas? En ligne et puis en salle, on n'a jamais vu un tel public. Nous recevons aujourd'hui deux personnes, nos stars. On vous remercie d'avoir accepté cette invitation pour la quatrième séance donc du séminaire L'œil numérique. C'était une séance qu'on a déjà dû déplacer. Elle était prévue en septembre. On l'a déplacée en janvier. Donc cette séance, elle sera consacrée aux apports des méthodes computationnelles à l'histoire visuelle, donc sur de grands corpus. Sur la base, Melvin, Wevers et Thomas Smits vont nous présenter donc un aperçu des méthodes des corpus, des grands corpus visuels massifs qui sont traités avec les outils d'intelligence artificielle, donc de machine vision. Voilà. Alors cette séance, elle va se dérouler en anglais. Là, c'est juste une petite introduction en français pour nous rappeler où nous nous situons. Elle sera suivie pour ceux qui sont inscrits. Je sais pas, je pense qu'il y a plus tellement de place d'ailleurs. Voilà, c'est ça. Ensuite, d'un atelier pratique qui va être consacré donc à l'exposé que vous allez nous faire, mais de façon plus appliquée. Voilà, je
Yeah,
te...
so we switch to English. So welcome everyone, and thank you for joining us for this fourth session of Digital Eye. And today's talk, a new lens on the past multimodal AI and historical image collections, starts from a simple question: what becomes possible when we can search, compare, model meaning across tens of thousands of historical images at once, rather than working with a small data set, and without having to reduce those images to a limited list of words, for example. And we're very pleased to welcome Thomas Smits and Melvin Wevers from the University of Amsterdam, whose work have helped define what they described as a multimodal turn in the digital humanities. And the idea is to move beyond the old division between text methods and image methods, and instead to study the image-text relations at scale, and by using such models such as clips and clip in their research. These models are not only tools for discovery, but also tools for analysis, and they will show us a few of their experimentation. And they insist on a crucial point that this system don't just reveal things, they also filter and distort, and we need to understand what they make visible and also what they tend to miss and what they tend to make invisible. So let me just say a quick word about each of our speakers. Thomas Smits is Assistant Professor of Digital History and Artificial Intelligence at the University of Amsterdam. He works at the intersection of visual culture history and computational methodology, and particularly, as I said before, on multimodal AI, not simply to index images, but to identify patterns that can reshape how we understand archives. For example, he worked on the Albert Kant archive, and he had a very important paper on this collection. And Melvin Wevers is a computational historian at the University of Amsterdam too. Just tell me if I say something wrong. And his works bring together multimodal machine learning, cultural analytics, large-scale historical sources. And he treats model also like as research tools rather than black boxes, and try to be transparent about what they are and what they do, and particularly interested in the question of training data and historical bias, and the way that this bias can change what we see through these models. So as Laurence said before, after the lecture this morning, we have this afternoon a workshop where we'll put this idea into practice and explore large image collection at scale through multimodal embeddings and learning how to use scripts and tools to do the things that I will speak this morning. And so it's a real pleasure to have to have you with us this morning. And I give you just the floor. So thank you, Thomas and Melvin, and the floor is yours.
Oh, I have to unmute myself. Yeah, thank you very much. And also welcome. It's always great to see so many people that are interested in digital methods. Melvin and I are always very curious about the work that is being done, which we don't know yet. So if you are interested in this sort of stuff, we are also very curious about what kind of work you are doing. So please also tell us that maybe after the presentation. But first, the presentation. Word of thanks also to Julien for the invitation and to the other organizers, of course. We're very happy to be here. We will do this in English, but you can try to ask me questions in French, and I might be able to understand them, but I definitely won't be able to answer them in French because my pronunciation is horrible, and I would want to put you through that. So let's start. Here we go. Yeah, there we go. So what we want to do today is basically answer a basic question, like how can AI help historians scale up visual research? And we will look at this question through three recent case studies of Melvin and I. So the first two use multimodal AI. One is on 19th century news illustration, and another one is indeed on early color photography. So that is the Albert Kahn collection Julien was just talking about. And the third uses visual language models, or so-called VLLMs, applied to housing registry cards of the city of Amsterdam. So it's a little bit more textual, but we also argue that these textual sources are in fact also visual. But Melvin will tell you more about that. As Julien already mentioned, AI models are often described as so-called black boxes, right? So we don't know we know that something goes in them, and we know that something comes out of them, but we don't know what is happening inside the black box. But this is exactly something that Melvin and I try to argue against, right? So we always say that historians need to understand the black box to be able to work with them. So we also will spend some time on explaining how actually a multimodal AI model works, and also how a VLM model works. Then we will end with some limitations, right? So what are the possible limitations and the pitfalls of applying these methods? And we will end with discussion and questions. So some quick context, also already mentioned, but this is all from a joint project that Melvin and I have been running since 2017, and where we have tried to apply different kinds of AI methods to historical visual culture. And in this period, the technology has changed very rapidly, right? So we have moved from what we called computer vision, so AI models that are able to classify images, to multimodal AI, and now to VLMs, so models that are able to answer questions about images, and who knows what will come next in the next years, right? So through all these shifts, we have tried to keep our focus on applying these techniques to actual questions from the humanities. So not applying AI for AI's sake, but really try to see how we can use them to say something about the questions that humanities scholars are interested in. So before we start, I also wanted to give some theoretical background. So I think it's very important that despite the fact that our societies have become more what Martin Jay has called ocular-centric, right? So focused on visual stuff, on images. Most of the humanities are still very much focused on text, right? So on studying large volumes or small volumes of text. And that for us is a problem, right? So we think that DA research has been way too much text focused. And the second problem, or sort of theoretical problem or starting point for our research, is that even when we do study images, we tend to approach them one at a time. And this is very much a result from like art historical methods, right? So, and this is sort of, for me, that's always been weird, because if you consider the scale of the visual culture that we are now living in, right? So since the first, there's a lot of debate, of course, about this, but the first photograph, the Boulevard du Temple, was taken in 1845. We have made around 3.5 billion photographs, and now every 2 minutes we make more photographs than were taken in the entire 19th century put together, right? So that we are dealing with huge volumes, but we only have the methods to study images one image at a time. So what do we need to study images at scale? We need digital methods, right? And especially we need machine learning algorithms. And that's sort of the first starting point of our research in this article we called the visual digital turn, right? So the application of digital methods to study large collections of images. And this is also what our colleagues, Taylor Arnold and Lauren Tilton, have described as the shift from close reading to what they call distant viewing, right? Which is, of course, a sort of a variation on Moretti's distant reading for literature, right? So distant viewing is also finding patterns in large collections of images. So, and this is the final theoretical starting point. When digital methods are applied to historical sources, digital humanities researchers usually separate what we call the different modalities, right? So a modality can be a text or an image. And we know from multimodality theory developed by Bateman and others, that the fact that that text and images in modernity or in modern forms, modern media, they create meaning together. So we cannot really separate text from images. And this is the picture you can see here on the slide. It's from Bateman's book. And he says, if all images are apples and all bananas are text, then the meaning of an image text is not apple plus banana, but it's something entirely different. It's apple times banana, right? So it's something you cannot say like, okay, if I know the image, the meaning of an image, and I know the meaning of a text, then I can sort of add these meanings together, and I know the meaning of an image text. You have to study these things in interaction. And that's also exactly why we are using multimodal AI, but also visual language models in our case studies, because they've been designed to learn from images and text together. So in a way, they are sort of mimicking how humans actually construct meaning. So now over to the case studies. And the first two are on multimodal AI. So I will first sort of give you a very brief introduction on how these multimodal AI models work. So this is going to be slightly more technical, right? So what we have here is a sort of a diagram of a multimodal AI model. And these models have been trained on nowadays billions of image text pairs. So images and text that describe these images that are all taken from the internet. And the multimodal AI model processes images and text simultaneously to what we call two encoders. So an image encoder and a text encoder. And these encoders convert images and text into numerical descriptions. So basically very long lists of numbers, and these long lists of numbers we call embeddings, right? So that's a very important word in the kind of research that we do. And the key sort of training task of the model is to align these textual embeddings and these visual embeddings. So the model has to learn to place these images and text embeddings in the same embedding space. So during the embedding or during the training, correct image text pairs, so the ones that are originally in the data set, are positioned very close to each other in this embedding space. And mismatches, so those are all the red ones, right? So text and images that do not belong together have to be positioned as far away as possible in this embedding space. And after processing billions of these image pairs, the AI model has developed a shared understanding of image and text together. So a photo of a red car and the word red are semantically similar, even though they contain different types of information. And this sort of shared embedding space is what makes these multimodal AI models very powerful. It sort of allows them to match images to text descriptions and textual descriptions to images without having to encounter that exact combination before. And this is what we call the zero-shot capability of these models. So how can we apply this kind of model in humanities research? In the 2023 article that Julia already mentioned, Melvin and I argued that these models could cause a genuine shift in digital humanities scholarship. So for the first time, we can sort of explore and analyze these image-text relations at scale. And we can do that basically by having a trained model extract embeddings from a large historical collection, and then use the embeddings of a specific query to match our query with the embeddings of the images. So now over to the case studies that will hopefully give a more sort of concrete idea of how we use these models. So the first is about the 19th century illustrated press. And this comes from my own PhD research, right? So I started out very traditionally studying news illustrations in the 19th century. And what we did here is we focused on what we call the first visual mass medium, the British publication, the Illustrated London News, which was sort of the most important illustrated newspaper of the age. And here we used another form of AI to extract around 72,000 images from the pages of the Illustrated London News. And then our question was, like, how can we actually use AI to retrieve what we call relevant illustrations from this visual haystack? So basically the question is, like, can we use these AI models to say, like, I'm looking for images of whatever, a dog or a horse, and then can I find them using these textual embeddings? So this is a movie of some code I wrote. Now it can all be sort of a Jupyter notebook, right? Which might be familiar to some of you. So what I basically do here is that I type in a prompt, so textual prompt. Here it's a steamship. And then the model turns this prompt into an embedding and it matches it with the images in the dataset. And you can see that without any metadata, so we don't have any information about these images, but the model is very good at matching images and text. So the same goes for more complicated or slightly more complicated concepts like horse race. And you see also that the results here are very relevant. And finally, I don't know what the last one will be. One of my favorite things, railway accidents. Very interesting for all sorts of in all sorts of ways. But you can see also that this is actually a very difficult visual subject, right? There's all sorts of different things happening if you think of a railway accident. But the model is actually very good at finding these images purely based on one short textual description. Then over to images, right? So you can not only start with the textual embedding, but also with an image embedding. So here we start with the modern photograph of a horse. And you see that the model finds all sorts of relevant images of horses in the dataset. And I think we can also find specific figures, right? So because there are so many images in the data set of CLIP, it has seen all sorts of different persons. So for example, here we have Queen Victoria, a photograph from the 19th century. I see that even if we have a very specific person, they are not all correct, but a lot of them are. Right. So this is sort of what we call retrieval. So using these models to find relevant images in a huge data set. And the second case study that I want to present on early color photography focuses on analysis. So can we also use the models to do some real analysis of these data sets? So not only find relevant images that we can then analyze in the traditional ways, but also use these models for really new kinds of distant viewing research. So this is in fact focused on the archives of the Planet collection, which is here very close to Paris, I guess, right? So it's which is a great collection. So you should definitely go there if you. I've been there once. They're all autochrome, so a great form of early color photography. And it's a huge collection of around 72,000 autochromes commissioned by the French banker Albert Kahn between 1909 and 1931. And he had a very specific goal in mind for this project. So he wanted to create, and this is a direct quote, a kind of inventory of the surface of the globe inhabited by man as it presents itself at the start of the 20th century. So what he did is basically commissioned photographers to go all over the world, but also a lot of them actually stayed just in France, but a lot of them also went to all sorts of different places all over the world, and then photograph a human culture that was about to disappear because of modernity, right? So because of the coming of the railways, that sort of stuff. And the question here for me was, okay, it's described as an archive of the world, but we of course know that we cannot make an archive of the world, right? That is basically, if you make an archive of the entire world, that's basically the world. So you need to make choices here. So what is in the archive and what is not in the archive? So who is present and who is absent? Who is visible and who is invisible? And these are very traditional humanities questions, which I tried to solve using multimodal AI. So we can already see some patterns of presence and absence if you only look at the metadata of this collection, right? So this collection has great metadata, which is, it's a humongous gift, I think, of the Albert Kahn Museum. So there's great metadata for every photograph. So we know where each photograph was taken. So here on the right, you can see sort of the pattern of presence, right? You can see all the small dots are where the photographs were taken. And of course, you immediately see, right? You immediately see the pattern. They are mostly in France. They are in Japan a little bit. They are in the Middle East a little bit here. But if we turn this sort of image around and turn the pattern of a presence into a pattern of absence, you see that most of the world is entirely absent from Kahn's inventory of the world. Using multimodal AI, I created another kind of map of this collection. So here I applied a clustering algorithm called K-means, which basically tries to sort all the embeddings of the photographs. So I used the multimodal AI model to extract embeddings from all the photographs in the Albert Kahn collection. And then I used this K-means algorithm to divide them into 12 coherent groups, right? So images that are closely related to each other in content or or visual content or contextual content. So what emerges is a map of the collection's visual and contextual content. So each color here represents a distinct cluster. And these aren't categories I imposed, but they sort of emerge from the data itself. So the spatial proximity on this map tells us if a photograph is visually similar, right? So if you have two photographs here, that means that they are in the brown cluster. That means that they are just basically a little bit of the same thing. And this is a way of seeing the collection as a whole. So this would be impossible through traditional methods, but it's now possible with AI. So what do we actually see when we apply this? So the slide that follows show 6 randomly chosen images from each cluster. So these are representative samples that reveal that the algorithm what the algorithm identified as visually and conceptually coherent groups. For example, here we have cluster 0, which I called European cities, and they all contain photographs of basically of these sorts of European cityscapes. We have also a cluster that is entirely focused on Japan, right? So a place that Kahn's photographers often visited. Or here, a cluster that is entirely contains pictures of people. And here we already see a very interesting fact, right? So the fact that the algorithm isolated people so distinctly tells us, I think, something very important. The rest of the collection, it means that the rest of the collection contains remarkably few people. So we can dive a little bit deeper and cluster the cluster, right? So now I'm using the same algorithm to cluster the people cluster. And then you can see all sorts of different groups emerging, right? So if we have men in military uniform, we have the cluster that mostly contains photographs showing families and children. We have this cluster of men and women from an African mission, as they were called, right? We have here people in front of their house. So the algorithm has found all sorts of different visual motifs in this people cluster. So we can also see patterns of presence and absence emerging here. So we have several clusters that show men. And one of them shows, in fact, men that are dressed in modern costumes, right? So these I've called them modern men. So they are all men in like modern dress. But there's no similar cluster for women. So while there were, of course, clearly modern women in this period, we do not see them in the Kahn collection, right? So here, by having an overview of the collection, we can get a better grasp of these sorts of patterns. Then the final thing, for an archive that was explicitly commissioned to capture culture, the Archives of the Planet contains also a remarkable amount of what we call non-human photography, right? So photography that doesn't show any humans at all. So basically photography of nature. For example, we have cluster 11 that contains around 1,600 images of trees. Or we have cluster 1 that contains 1,000 images of all sorts of mountain scenes. And we can also cluster cluster this cluster, right? And here we can see all sorts of things like there's a cluster on valleys, there's a cluster on fast running rivers, there's a cluster on snowy mountain peaks. So when Kahn, this sort of tells me when Kahn spoke of this disappearing world, he was thinking, of course, primarily in terms of human culture. So the practices, traditions, and ways of life that were disappearing. But now, because of the climate crisis and the massive loss of biodiversity, we know that the collection also captured a lot of nature that was about to disappear, right? So by having the multimodal AI model sort of make an inventory of the entire collection, we can see these patterns way more clearly. So the final thing, if we have this sort of this distant viewing of a collection, what do we do then with close reading, right? Do we still need to analyze images one by one? So in my view, distant viewing a collection with digital methods should in fact not replace close reading, but it can provide a way better basis for it. So using large-scale patterns, we can identify images that are truly representative of a collection, both the typical but also the exceptional or the atypical. And this is how computational methods can strengthen traditional historical visual analysis by ensuring that it's anchored in not in sort of subjective selection, right? So that you just basically choose a random image and then start to interpret it, but in the sort of the systematic analysis of an entire collection. And we can take a quick look at one example. So here I used a different clustering algorithm to cluster all the images in my collection of the Illustrated London News. And you also see here that there are lots of clusters that are focused on different types of men, right? We have clergy, we have sort of military men from the Ottoman Empire. These are soldiers, some of them French, from the French army, right? So we have different sorts of men in different kinds of professions. So we can then move from these clusters to a close reading by selecting the image that is most representative of a specific cluster. So here what I did is have a computer calculate the centroid of each cluster. So the image that is most representative, most in the sort of the central point of a specific cluster. And here we can see the cluster 17, that was one of the cluster with almost 900 or 950 images of portraits of men. And we have one image that is at the center of this cluster. And this central portrait of cluster 17 is, from a mathematical perspective, the most representative portrait of a man according to the multimodal AI, right? So this guy, General Walker, whose portrait is located on like a small part of the page, so it's not a full page portrait, but he is in fact sort of mathematically the most manly man of all the men in the Illustrated London News. So if you're interested in sort of representations of gender and that sort of stuff, this is actually, I think, an extremely good starting point to close read and interpret images, right? It's not like the most well-known guy, but it is, in a way, he is the most representative guy of the entire collection. I think that can tell us a lot about what we are as visual historians and humanities scholars traditionally interested in. So.
Yeah, I'm gonna stand for a bit because I have to point at the screen a couple of times. So Thomas just spoke about multimodal AI and mostly about the CLIP model. I'm gonna shift to something more recent, vision large language models or vision language models. A quite recent development that sort of builds on what CLIP has already provided us with. This can be quite daunting, so I will very briefly explain what the difference is between these models and what CLIP offered. You probably have used ChatGPT or Mistral in France, like a AI system with which you can communicate in text, right? So this is basically something that is built on these models, so these LLMs, these large language models, but rather than just talking with the models, we can also upload an image to the model and ask questions about images. And so it can be a conversation about an image, where Thomas just showed that we can ask, like, give me an image of a horse, it gives you a horse. But now we can also ask questions and the model tells us what's on the image, perhaps. And how this basically works is that we take these very large language models that have all kinds of knowledge about the world, but we also inject a lot of images in these models, and we project these two dimensions onto each other. And then we have information on a lot of images and information on a lot of text. And what the people that make these models then do is expose these models to a lot of questions and answers that they have defined beforehand. And they want the model to be as good as answering the question with a good answer as possible. And then the way that the images and the text are combined is optimized so that it can answer the questions you ask of the model. That's very much in a nutshell. And what is important here to remember is that the text that you upload is turned into numbers, just long strings of numbers. But also the images that you upload are turned into long strings of numbers that are then combined. So for the model, it's just numbers. It doesn't matter if it's an image or if it's a text. And remember when Thomas started, he said, we want to look at this distinction between what is a text and what is an image from a multimodal perspective. In a way, this might be happening in these models as well. And it's something I will talk a bit more about. This is an example. A lot of times when we use these vision language models, it is in this sort of almost close reading sense where we take a single image, we upload it to the model, often through the interface, and we ask questions about the model. This is an example of an image that I uploaded, and I asked, what do we see on this image? And then the model gives you a prompt back, an answer. We see a large billboard for Coca-Cola with the slogan, "Enjoy Coca-Cola," which is actually on the thing. It's situated in an urban area with a city skyline, tall buildings, skyscrapers, highways, and roads are visible, indicating a busy transportation network. So that is already a little bit of interpretation. The sky is clear, suggesting a sunny day. The overall scene suggests a bustling city environment with a focus on advertising and consumer culture. So in a way, when we do like a media studies course and we have to analyze photographs or movies or video games, we also train ourselves to sort of analyze images. And in a way, the model is trying to do this. But if you ask a follow-up question, I ask, well, okay, you say it's a city, but what city might it be? The model says it goes into the city skyline again, but without specific landmarks, it's difficult to determine the exact city. But the architecture and layout suggest it might be in the United States, such as New York, Chicago, or Los Angeles, which are known for their skyscrapers and urban landscapes, which is a bit generic, right? There's many other cities with skyscrapers. I happen to know which city this is, and I tell the model it's San Francisco. And then it says, thank you for the additional information. It is indeed San Francisco, and now all of a sudden it knows. The distinctive skyline with the Transamerica Pyramid and other notable buildings is characteristic of the city's downtown area. And the presence of the Bay Bridge in the background further confirms the location is San Francisco. But if we go back to the image, we don't see this Bay Bridge. It's not there. So the model knows that the Bay Bridge is in San Francisco, the Golden Gate Bridge, right? And it infers that it's sort of there. But also this Transamerica Pyramid is also not in this image. So it comes up with all these things that are not actually in the image, but is sort of more contextual. And this brings me to one of the, and I'm going to point out a lot of limitations as well. So we'll be a bit more pessimistic about these models to some extent. But what these VLMs do is that they blend multiple types of information without clearly saying where it comes from. So in a way, they do visual observation, what is actually represented in the pixels. So here we have an image a little bit hidden of the Eiffel Tower. So in terms of visual observation, the model would say it's a tower with an iron lattice structure. Not a lot of interpretation, just a very generic description of what we see. The other thing it might do is do visual inference. So interpretation based on what we see. So it says this appears to be the Eiffel Tower. It doesn't say in text that this is the Eiffel Tower. Based on what it sees, it might say it's the Eiffel Tower. But then there's also external knowledge, facts that it knows in this large language models, who built the Eiffel Tower, when it was built, that is not captured in this image itself. And these are all kinds of different sources of information that the model presents, and some of it comes from the language model, some of it comes from the images. But we don't really know where it comes from. And I think as scholars working with images, single images, but especially when we do it at scale, we need models to allow us to distinguish if it makes an interpretation, on what is it based? Is it on the visual part? Is it on the contextual part? Is it an interpretation? Especially since we are both historians, and for historians, but I guess for a lot of humanities scholars, knowing what is actually in the source, what are we reading in the source, and what is our interpretation is a very important part of what we do. But at the same time, images are also open to multiple interpretations. That's sort of the critical analysis of images. Your perspective, your own ideology might shape how you interpret the image. So in a way, we cannot. We should also allow the model to have some flexibility in what it presents us with. So that is one of the issues of what these VLMs do that might need more input from humanities scholars to see if we can tune these models to be a bit more transparent about this. But at this point also, in working with these vision language models, made us think about what are we actually analyzing now? Because for a long time, when we uploaded images, we did OCR or HDR, which are also sort of vision models to just extract the text. Or as Thomas showed, we extract the illustrations, take the illustrations out. But maybe with these models, we can also think about approaching the image as a multimodal object, where there's image and text relationships on the image, on the scan, basically, that in their interaction constitute what is being said on the image. So rather than here doing an OCR or getting some of the images out, we try to view this holistically, so everything together, basically. This is an example from a gaming magazine from the 90s in the Netherlands that has a very distinct style, and some of it is also a little weird. For example, here they give scores for games, and they give the graphics a 7.5 and the sound a 7.7, but they still end up with a 9. So if you would only extract the text and you would add up these two numbers, then the 9 wouldn't make sense. So you need the textual interpretation, maybe how they highlighted some of these aspects. This is a complicated problem that we haven't solved yet, but it's something that we are very interested in thinking of ways to solve this. And one of the sources that actually confronted us with this problem that we started working together with our colleague Tim Verlaan are housing registry cards. And so in a lot of archives, there are a lot of administrative sources, so sources that just process all kinds of information that at first sight look a little bit boring, like just admin stuff that people document all kinds of stuff. But these cards are actually in the city archives of Amsterdam, and what they do for every single street in Amsterdam and every single house in Amsterdam, they registered who lived there. So when they moved there, when they moved out, how old they were, and where they moved. And for a long time, these scans were online, but just the scans. There was no OCR, there was no HDR. And when we look at these, you can investigate this one address But imagine there's 450,000 of these cards. You could investigate like migration patterns in Amsterdam, certain streets that have a lot of turnover, so new people moving in. How old were the people when they moved in? Housing is a big issue now in Amsterdam, it's probably the same here in Paris. So these cards might shed light on that problem. But going from this and reading this as a human, it's quite easy for us to read it because it is a table. Tables are often easy to read. But for computers like this, tables are actually quite difficult. So a question that, and there's many reasons that I will get into in a second why it is difficult. For us, can we use these VLMs, so these vision language models, to turn this into structured data and approach this as a multimodal object? That is one of the recent projects we're working on. And we tried OCR on this, and it failed horribly. One of the reasons is because you can look at this as a line, but there's actually a structure there. It's actually columns. But in this case, this line continues here. So if you would have a column and see this as two different lines, it's actually the same object. We know this because there's a number here, and if there's a new number, it's a new line. So that's sort of a rule that is encoded in the table. And there's all kinds of these rules. So this is the date when people arrived. This is the date when people left. As humans, we know that this always has to be in front of this because, yeah, people cannot leave if they're not there yet, of course. And these are all kinds of things that an OCR model just looks at what's on the page, but we have extra knowledge about what is on this page. So can we feed this extra knowledge into a model to help us extract what is on the page? So how are we going to do this? That's a big question for us now. And we are running experiments now where, well, maybe I can take one step back. So I just said we know things about these cards. We have information. The same as when you talk with an LLM, with ChatGPT or with Mistral, how you prompt is very important. Like how you ask the question is very important. The same goes when we upload an image like this to a VLM. If we just say extract everything that's on the page, it will attempt to do it. But of course, we know more about this. We know that this is a housing registry card. We know that this date has to be in front of this date. So having this information and giving it to the model really helps. But yeah, to do this, it was actually quite a difficult process because these cards have multiple sections. So what we did is we cut them in multiple parts. So we cut the header and this part, and there's also a part underneath here. And basically, oops, this goes a little too fast. We feed these separate parts to a really big model, a model that costs a lot of computer power to run, and it's pretty slow. And remember, we had almost 500,000 of these cards. So if it's really slow, it's going to take months. And for every separate element of the card, we give it a separate prompt. So for the header, we would say, oh, there's an address here. These are possible numbers of the address. It has to be within a certain range because we don't have houses with number 5 million. So we can have all these rules to help the model. We've done this for a sample of cards, and then we got structured output. So basically like JSON files or CSVs that we can manually correct. So we have an annotation tool to fix what's on like 200 of these cards. But the thing then is we can use these manually corrected cards to fine-tune a smaller model. And a smaller model is easier to run. It doesn't take as long. You can run it on a laptop, but on a decent computer, you can still run it. And by fine-tuning these models, it's probably also a discussion here. We can use very big models that cost a lot of energy and that can do all kinds of different things. But here we only want them to do one thing, these housing cards, and process them. So by giving them very clear instructions, we can make these models very specific to the task we want in a way that's more cost efficient, and it's also faster. But if they're too small, the quality becomes bad again. So it's a difficult way of finding the balance between how we do this. Also, these are all open source. I say open source because in part they're open source models. So rather than using OpenAI models. And once we have this fine-tuned model, we can run it through all the cards and get structured data. We're still in the process of doing this, but this would allow us to answer these questions about like migration and turnover, etc. I'm going to speed up a little bit. So now some limitations. So Thomas mentioned the CLIP model to do the multimodal embedding. So the things he showed with the Albert Kahn collection and the illustrated news was all done with the CLIP model, the embedding model. This model is also part of a lot of VLM models, so to turn the images into a set of numbers. But these models have some complications, and you probably have heard of some of these. They've been trained on data from the internet, and a lot of data on the internet has strong biases. In terms of culture, like most data on the internet is from the Western world. There's a temporal bias. For us as historians, this is very problematic. A lot of data on the internet is fairly new. There is some historical material, but not a lot of historical material. So this causes these models to have certain biases in terms of culture and time. This is a very classic example where if you ask a model to match a prompt to the image, an image of Barack Obama, the model actually says that the prompt, this is the portrait of a former president of the United States, which he is, right? Or you give it the prompt, this is the portrait of the first ever illegal president of the United States born in Kenya, what Donald Trump, of course, was saying many, many times. So there are a lot of that, well, nonsense is on the internet. The model actually says, well, that prompt matches the image better. So, well, that's obviously not true, but in terms of the data that's on the internet, it's a better match. So there's many of these examples that show that these models, if you give it images of or you ask of images of nurses, for example, you get a lot of very erotic looking nurses, because that's also a lot of that is on the internet, of course. Then there's a second problem. A lot of words have multiple meanings that are often opposing. Here we have an example of the word palm. So if you ask for the word palm, you might get this, a hand palm, or the tree, the palm. In the embedding space, they're both close, but they're actually quite different. And the models cannot really deal with that very well. There are some attempts now to separate that, but of course that can lead to all kinds of downstream issues. A second issue is that models are pretty bad at things that are really easy for us, position on images. So here are examples where you just have an image of a rabbit, and if you ask the model what the orientation is it facing left or right? The models often make mistakes with that. Counting things on images, very simple task for us most of the times, very difficult for these models. And sometimes, like extracting text, of course, I just showed you the VLMs, they're much better at this, but with CLIP, sometimes it has a lot of problems extracting text. And in a way, this is a bottleneck that cannot be solved by just feeding it more data. The issue is that CLIP itself has sort of a very high level understanding what's on an image, but not a very detailed understanding what's on the image. So people are now working on actually decomposing the image in multiple separate objects and blocks, and then feeding it into models, and then bringing that information back again. But that's, of course, a much heavier task. So this is a very complicated issue. I remember the image I showed of San Francisco. If you would ask, where is the skyscraper? Is it on the left or the right of the image? Then the answer would oftentimes be a little bit wrong, because it often doesn't really use the image itself, but just some, if on the internet, there's more text saying that skyscrapers are on the left of images, then there's a higher probability that the answer might be that is on the left. Now to some conclusions. Even though there are these limitations that I've highlighted, we still believe that these methods give us unprecedented access to images. Working with this many images, these large collections of images, and often image collections have very poor metadata. They're not really described very well. They give us the opportunity to query them, to highlight very particular images in collections, but also to analyze patterns in collections. And the thing that interests us is to what extent can we bring theories from media studies, visual history, back to these images and test whether these theories hold if we look at images at scale. Because a lot of studies use very limited amount of images and make very big claims about visual culture. But we also turn it around sometimes. So we bring the theory to the machine learning, but in using machine learning, it also makes us rethink about theory again. And in the example I showed about the visual language models, it actually highlighted for us again that for a long time in media studies, there was a debate on whether we should focus on text and images separately. And then there was the multimodality theory by W.J.T. Mitchell, who said, well, we should do this together in interaction. And he got a lot of criticism back then, saying, no, we have to separate it. Text is for the text people, images is for the image people. And even in machine learning for a long time, we did this. We had computer vision and we had natural language processing. These people doing the text, these people doing the images. But we feel now with multimodal AI, with CLIP and with these vision language models, it is actually making it more complicated to do this separately and even allowing us to think about text, as W.T. Mitchell has said, as multimodal objects. He said there are no purely visual or verbal arts. It's just a mix of both. So in a way, the VLM isn't turning our sources into something that is multimodal, but in a way, it's sort of highlighting, surfacing the actual multimodality. And this is still in a very early stage, I think, for us, but thinking about ways in which we can analyze these very complicated images, like the example I showed of the gaming magazine, but then doing that at scale, so not just one image, but across thousands of images. I think that allows us to then really think about how is meaning constructed in a text that contains text and images. I think that was the last slide. So questions, I think, or a little break. I'm not sure what the plan is.
Yeah.
Yeah. Thank you.
Yeah, thank you very much. I'm going to put back my audio on. If there are questions online, don't hesitate to ask them. And if there are questions here, I'm pretty sure that there are people with a lot of questions or maybe on things that they are working on right now that are similar or problematic. So don't be shy.
Don't be shy.
Yeah. I have a few questions for you. I can start just a little. Particularly these last slides and the question about multimodality and how to think about this object. For me, also something you didn't mention, I think her name, Joanna Drucker, worked a lot on the concept of graphesis and the idea that text is also an image, basically. And so have you worked on the culture of the page, like the way people think about what is a page and how it organizes knowledge and text and textuality, and how you could walk through this format to try to extract knowledge or to generate new standards or new ideas? I don't know.
Yeah, maybe I can start and then you can say. So one thing, so I worked a lot on newspapers, historical newspapers, and for a long time, people did full text search to find an article to be able to read them. But one thing I did is looking at where the advertisements were on the page, and to do that across many pages. And in a way, the thing that was quite revealing is that, of course, you see that the number of advertisements increases, but also in advertising, there's often this theory that you flip the page and then you look at a certain point at the page, and this is where the advertisements are. I think I have to. And actually, by looking just at where the objects were, like the bounding boxes of the advertisements, I could confirm that theory that the advertisements were there. But at the same time, you could see that there were certain shapes that people could basically buy, like you buy an ad in this shape, and then over time, people had more flexibility to do that. So that was a little bit in the direction that you were saying. Yeah.
No, my basic thing would be that's very, and I think that's always has been a problem. Like, what is the sort of the main object? So what is the category we are interested in? So what is the sort of is it indeed the page, or is it the article, or at what level should we approach these sources? So yeah, it can be so. And what I think is what these VLMs also in applying them really show is that again, that even like very simple looking textual data, right? So as these housing registries cards, they are in fact very complicated multimodal objects, and that we as humans do all sorts of things to read this text, and it's based on the textual features of this page or of this sort of object and table, and that we can actually sort of approach that by using these new kinds of methods.
Question. Yes, thank you very much for the talk. You presented the two ways to see to have access to the pictures and to the text, and you can study the text or the pictures with visual models. But have you also worked on describing the picture with the LLM and use the description, the textual description, as an access to the image? And have you found differences or different way to work with that? Have you considered working with this method?
Yeah, so no, we have not done this ourselves, but it's a thing that's often applied by other people. So our colleagues Laura Tilton and Taylor Arnold have done it, but it's now a lot of people in like computational social sciences also use this kind of stuff. Or I know of a very good article about images of climate change. But then I think like what you're actually doing is you're sort of analyzing a derivative. So, for example, for the article on climate change, what they did is like they had a VLM describe images, and then they clustered the text into textual clusters to find these sorts of these sort of clusters in this visual representation. But then, as Melvin already showed, like these VLMs, they make they describe these images based on the image itself, but also on all the knowledge which is in the LM, which is huge. So it's basically, I think, like then it becomes very complicated what you're actually analyzing. So the results will be great, and they will give you an overview, but it's also like, okay, how much of that clustering is dependent on the information that is in the LM? And that's of course the same thing when you apply a multimodal model, but there I think it's slightly more clear what the influence of the AI is.
And I think two things to add is I think it's very important when you start doing this that you have a theory of what you want the description to contain and why it should contain this. Because if you have this, you can use this fine-tuning of models as well to almost force the models to only do what you want it to do. Because if you have it make descriptions, it can make a description of 1,000 pages, and the first 50 words are reasonable, but it becomes more nonsense as you go on and on and on. For some images, it's like it's a dog. There's not much more to say. But if you ask, give me 50 words on the dog, it will tell you 50 words. Maybe for another image, you might want to have 250 words, but if you say 50, so it's very difficult to determine what is the level of description. Of course, you can think about that beforehand, where you can say, okay, I want you to focus on these aspects of the image. And that's a little bit with the VLMs. If you give it a prompt, and you can also give it examples in a prompt, that helps. And the second thing is I did a very small experiment with a collection of colonial photography in the Netherlands where I tried to do this. And then it becomes very complicated, because then you can immediately see the cultural bias of these models, where when they start to describe something from a culture that is not very clearly represented on the internet, it comes up with all kinds of descriptions where it's just sort of imposing its Western bias on these models. So for example, in that collection, it was a very specific example. There were many different kinds of swords that were used. And it was very important what kind of sword or knife they had, because it belonged to certain subcultures on certain islands in Indonesia. But the model will say, oh, it's a sword, it's a knife, it's a sword. And that was so generic. Even if you would say, this is a list of possible swords, choose from it, it would have of course you can fix that in a way by giving it more knowledge. But these are things that I think it has use, but it has to be the experiment has to be very clear, I think. Yeah.
I think what you say about the Indonesian types of knives and swords, would it be like a barrier to the answer to have only the knowledge in a specific language? For example, in Indonesian languages, you will have only the terms in the local languages, and they will not have good translations in English. For example, if you prompt in English,
Yeah.
your description will be not as rich as it could be if you prompt in another language.
Yeah. And there's a positive side and a negative side to this, because sometimes people want to have models for French, models for English, and very specific models. But by training it on all kinds of different languages and putting it all in one model, you also get the words in different languages are close to each other in a model. So even if you have maybe 100 examples of sword in English and maybe 5 in French or in Dutch, it can infer that because of all the information in English, the French and the Dutch become better. But that is if there's a one-on-one relation between. But if it's like all kinds of, if a language has many more words for a certain object, then the frequency of information becomes much lower. So then you run into these issues. Famously, I think people say that some languages have many more words for smells or colors. So it is tricky to have enough information to do that.
It can also be a positive thing. For example, in the Netherlands, I'm sure also here in France, we have many colonial collections which we collected, right? So in the colonial times, and we are in the process of giving these collections back in a way, right? We want to give them back, or we want to provide access to them from people from former colonized countries, but we have no metadata. So it's very hard for somebody in Indonesia who only speaks Indonesian to search through these Dutch databases. But with a multimodal model, he or she can actually use Indonesian search queries to find relevant images for them. But then the problem is that, of course, because English is the largest language on the internet, that everything is mapped back to English. So the parts of the Indonesian language or the French language or the Dutch language that are specific to that language, which cannot be mapped on English very well, we sort of lose that. So it's like you get more access, but you also lose cultural specificity, I guess.
Je me permets de poser la question en français, comme ça.
Oui.
J'ai un problème en fait un peu avec ce terme, mais pas seulement avec votre présentation, d'interprétation. Pour 2 raisons. Bon, il y a une raison qui est basique, une épistémologie. Qui peut interpréter? Est-ce qu'une machine peut interpréter? Bon, c'est une question très générale. Mais aussi parce qu'on lui donne à interpréter en fait des données qui sont très incomplètes. Moi, ce qui m'a frappé sur l'exemple de votre l'image avec le San Francisco, la vue San Francisco, il n'y avait rien sur la composition de l'image, il n'y avait pas de reconnaissance des motifs, il n'y avait rien sur les couleurs. Alors, même avec ça, c'est impossible déjà de parler d'interprétation. Et même si on redonne d'autres données, jusqu'à quel niveau de données de transcription de données, d'ingestion de données, on peut parler d'interprétation. Alors, c'est un problème en anglais. Moi, je parle mieux allemand qu'anglais, je peux dire. Et je crois que, par exemple, en allemand, je pense que vous parlez tous les deux, on pourrait parler de Bearbeitung. Trouver quand même, peut-être aussi ne pas utiliser tout de suite ce thème d'interprétation qui prête à confusion. Alors, à quel moment est-ce qu'on peut en parler tout court et à quel moment on peut en parler? Ça me semble très important dans la transmission des données, dans la transmission du savoir, dans la transmission aussi de ces modèles multimodaux. Enfin, voilà, c'est une question, mais c'est une question un peu de fond quand même. Est-ce qu'il ne faut pas faire attention à utiliser ce mot tout court ou ce mot trop tôt?
Yeah. Thanks. So, like, I hope I understood you correctly, but I think I did. So, like, for example, I think, like, so who's interpreting, right? So, I think for us, it's always the historian who's interpreting. So, we have lots of what we also call, like, derivative things. Like, so, for example, if you go back to the Albert Kahn collections, like, I am interpreting. So, me as a historian, I am interpreting these artifacts of the model. And I think it's also necessary because for me, in a sort of philosophy of science way, interpretation has to be linked to a person. Like I'm a very like traditional Gadamer kind of historian, which say like, okay, my own personal standpoint, that is what makes the interpretation, right? So a model, of course, has no standpoint. It has no specific specific point in time and place where it can interpret from. So a model is, I think, for me, we differ here. So like this is a huge discussion in our room. But for me, I think like a model cannot interpret in that way, right? So because it has no clear vantage point on the world, but it can help you generate these artifacts, these overviews of collections, which a historian or whatever, a humanities scholar can interpret. So, and I think like what you see, the second part of the question, it's a little bit harder for me, but I think what you meant is like what Melvin was talking about here. We ask for the model to interpret this image, but of course I think it's not interpreting, right? It is, as we often see in LLMs, it is mimicking something which resembles interpretation, but it's not interpreting. In fact, it's not interpreting, it's just generating words based on the input, the image, plus the prompt, it generates something. This is also something that Melvin thinks, I think, a little bit different about, but that would be my answer. I hope
Yeah, and I think one thing I sort of get, my French isn't that good, but you also said something about composition, right? And how composition is meaning as well, right? I know in art history, people have very clear or clearer ways to analyze images, and also where things are located on the image, and we can use that. And I think the difficulty here is when this is a very general question, what do we see on the image? If we ask, what does it mean that Coca-Cola is on there? It's a sign of consumerism, blah, blah, blah. That's also still very associative. We know Coca-Cola consumerism. If you would have told me I have an image with a Coca-Cola sign in San Francisco without showing me the image, I could say, oh, it's about consumerism, without seeing the image, right? So I think if we think that the composition or the use of color gives us a specific insight in that image, we have to model that very specifically. So sometimes our point is not we should always use big AI models to do it. Sometimes we have good theory about what's happening in an image, and if we think of a way, how can we use a computer to get that part out of the image, just that one thing that is important for that theory, and think of a way to do that, we can do it on one image, but we can also do it on 100 images. And I think we might need many different ways of decomposing the image and getting information out of the image and then combining it. These models, they look at the entire image as one list of numbers. They don't care about the size of the thing. And so I think in doing that, we basically need to think of different tasks and operationalize them for composition, for example, and other things. But yeah, I don't believe that this is the way to do this. Yeah.
Just a follow-up question, because I actually tried to personalize Panofsky, so to try to effectively use different models to like segment the pictures and then try different interpretation at different levels of the image. Have you tried something like that, agentic AI, to try to work together on the same image to get a result and not just one treatment at a time?
Yeah, I think that is what I would propose, yeah, to do it in such a way. Of course, the difficulty is that, if you take this example, what do you segment? Do you segment every single line here or this? What are the important elements? And you can also use the models to show where the attention goes for the model. What is sort of the important thing in the model, and then decide what to segment on the model. So I think by decomposing the image in separate parts and thinking of it as more of a network of objects, and then having different agents doing different things. I've only thought about this. I haven't in practice done it, but I think that is probably the way to get to a way that is generalizable. And then we differ a little bit, because I think the interpretation in the humanistic sense, you cannot scale that across thousands of images. But then the question is, why do you want to scale it to 1,000 of images? What do we learn from? And that's a debate. I think it's a different purpose, I think. And I think it has to be both in a way then. Yeah.
I would also be, just very shortly, I would be very careful with like attributing too much difference to different agents, right? So we also think different about this. So I already know what Melvin is thinking when I say this, but like if you have different agents, AI agents, for me, they're basically doing the same thing. So you're basically creating 5 different things. So you think they do different things, but they all are basing their interpretation or their text they generate over the image on the same kind of parameters, the same kind of models. So you're just combining stuff. It looks like people are doing something, and also terminology is extremely confusing here because they are called agents and that sort of stuff. But I just think it's basically the same model doing lots of different things, and then you recombine it. But yeah, maybe that's something not to get into now. Yeah.
About the algorithm of clustering, how do you choose the number of clusters?
Yeah.
Is it like it's empirical and then after you name it afterwards, or how do you do that?
Yeah, that's a very good question. So you have different clustering algorithms. So notoriously, K means you have to preset the K, right? So you have to choose the cluster. So here I did this is based on a method called the elbow method. So you can determine sort of the optimal what's the best way to explain this?
Number of clusters.
Yeah, the optimal, but it's not really, it's not the optimal number of clusters, but you can interpret where the model, yes, I have to explain how, I have to think how I would explain the K method now. Like,
the elbow?
Yeah, the elbow. Is that how?
Yeah, well, I think
it's the optimal density of the clusters.
Yeah.
That's basically what you're trying to find. So you can say like, okay, using this elbow method, you can get the mathematical optimal value of the density of clusters. And then you get like a number. So you say like 12. That's of course not, what the problem is here is that you of course also can have data points that are not really part of any cluster, what we could consider noise, right? So this, you can also use different kinds of methods. So this clustering, is actually based on another clustering algorithm called HCB scan, where you don't have to preset the number of clusters, but there it is determined by the method itself. So it can also say like we have some images that are basically noise, so they should not belong to any cluster at all. And I think now I would say like for most applications, I think this HCB scan model is better because then you get a clearer sense of what is actually a coherent cluster mathematically and what is considered to be noise or outliers. And these noise points are also interesting because they are interesting to interpret them as well. So yeah.
And I also think your approach of having a cluster and then clustering the cluster again, so you get a hierarchical cluster. Some clusters have subclusters, but some don't. And if you would ask you could also make more main clusters, but then sometimes Thomas' approach of clustering the cluster, if there's a lot going on there, you can also have the human be in the loop then, and that can be a smart way to do it, I think.
There was one question about the picture just before this that topic of the maybe, but the one of the most representative of a man. Like, how do you find it? Because it's in the center of a cluster, or because it's more linked to world or something, or I think there is biases of the model within the idea of having one behind the in the whole cluster of it. So I'd like to do some more.
Yeah, that's a great question. So what you get here is like I calculate the centroid. It's called the centroid based on the embedding. So basically, this is a very high dimensional space, and then you have all these points, and you can calculate which point is the most central to all the other points that are in the same cluster. But the second point you made about the bias of the model, that's very true. So we have a good colleague of ours, Leonardo Impet. He wrote an article based on an article of Joanna Drucker. It's called "Is There a Digital Art History?" And their article is called "There is a Digital Art History." And what their main point is that if you apply a model to historical visual material, you will always learn something about the material, but also about the biases of the model. So when the model tells me that this is the most manly man, it tells me something about the men in the historical collection, but it also tells me something about the idea of the model of what a man is. So this is a very complicated sort of loop where you project our idea of gender on the 19th century and then project them back again. So you're definitely right. It's very important to keep that in mind. But then I think we don't have it here, but Melvin and I often use a picture where we say like, okay, it shows a little child with his mother, and he says like, mommy, all the computers are biased because they only know what humans have taught it. And then the mother says, but so have you, right? So we also have our biases. So I'm not quite sure if like selecting an image and then interpreting it is better in that sense, right? The bias of the human is way more important. So I still think this is a better image to interpret if you're interested in gender in the 19th century than just another image. That's sort of.
But you used clip to make the cluster, no, or something like this.
Yeah.
Another model, but it's trained with like modern images mostly. So you use like the biases is more like modern biases than one that could be in the 19th century, for example. So it's like, I think it's just difficult to interpret in a historical point of view, I think, but I don't know if you agree with this, or you think we can interpret in modern point of view?
You're definitely right. So, but there's thing is, so like I think we see that the model still, because it is biased, but bias doesn't mean that it's entirely wrong, right? So it's still these clusters that exist in the collection, they are still relevant, right? So it still finds these men in different professions and in different things. And also very tellingly, it only finds, I didn't show the slide, but it only finds 2 clusters of women. And they are also only portrayed like in a wide variety of senses, right? So it has found these different types of men, and then it can also see like, okay, which of these images are just purely the most similar, and there's bias in that, but I don't think that bias means that it's not useful anymore. It's just something you have to take into account when you interpret them, and be very clear about always.
And I think your point you raise is almost the start of a new research paper again, because then you want to understand how much of it is sort of the modern part or the historical part. Does it change for men, for women? There are some interesting papers that also try to untangle this, and we had this example it's not in here, but where we looked at trains, and trains work really well because trains, they look different over time, but still the models are able to cluster trains. But if you have telephones, a lot of the images of telephones are like the modern iPhones and stuff, but not like old the where you would turn, right? So the model would find those much more difficult because they look different, but because clip is not just visual, it has also the textual. So even because of that semantic part, it was still able to sort of join it, but on a visual level, if you would just do visual similarity, then they would be very different. So that's also a tricky thing there, like how much, because there are of course older images also on the internet, but how are they described? So yeah, it's a complicated problem, but an interesting one, yeah.
I have another question with working with archives and historical documents. Do you, I don't know, did anybody or you manage to measure the weight of the material on the outputs of the model compared to the weight of the depiction? Like photographs, we go with photographs rather than men with men. I mean,
I'm not quite sure if I understand you. So
like all these people that are like men, but most of them I think are drawings.
yeah.
And for example, if you have a picture of a man, will it go with the man, other drawn man? Or will it go with other picture and to manage to measure like the impact of the strokes?
Yeah, that's a very good question. So like what you could there are some experiments with it. So this is basically, it's all illustration. So that makes it easier. So there's no photograph of a man in there. But that is for clip, I think they would mix. That's something you could measure, and you could also try to separate the things. So like what you could do is an embedding is a very high dimensional numerical representation. But what you could use is a couple of tricks, like something we call principal component analysis, where you try to flatten the embedding into like only 4 dimension or 12 or like 3 or whatever. So also because if you want to create these sorts of representations, you flatten them down to 2. So what you could try to do, and what people have done, is that you say like, okay, I cannot show you anything, so keep it like this. But what you could try to do is like, okay, if we use principal component analysis or a different method, do we see like that some of these components contain information about the medium, so photographs and illustrations, and other about the context or what is actually on an image? So that could be one way to approach it.
And the models are also really good if you ask, give me a photograph of a man or give me an illustration of a man. So you could also separate the collection beforehand into 2, then do all the analysis and then bring them back together. And then within that, apply the embedding.
Could you prompt clip in natural language?
You could do that if you want. Yeah.
So you could also, that's something you could like, you could use clip very easily to add like a lot of metadata to a collection very fast, right? So you just fine tune a clip model just to say like photograph, illustration, like that's a very like reasonably easy process, and it works really well because you can reuse the same embeddings over and over again.
Your last question or commentaries? Anything? No? All right, I think that's it. Thank you so much.
Thanks.
So now, if there are other questions, we can have a little one at the break over here. So now we'll have a short break for lunch. People that are registered for the workshop can come with us for lunch. I'm sorry, we don't have lunch for 30 people, I guess. So and after that we will come back here for the workshop. Thank you again to everyone here and online. The next session of the seminar will be, I think, in March or April, or in May, even in May. So we'll keep you posted. Thank you again, and have a good day. All right.
Thank you.